In Chapter 11, Section 6, we're going to be talking about what the persistent challenges are considering water and water quality. We'll talk about developing countries and some of the struggles that they have with water pollution. We'll also talk about how to clean up groundwater and why it's hard to clean up. And we'll also talk about ocean pollution as well. So our first persistent challenge to water quality is developing countries, and they're going to often have serious water pollution. And a lot of this comes as a result of just the cost associated with having water treatment plants or pollution control technologies. It's going to require billions of dollars, and developing countries just don't have that. It also requires established professional agencies that are going to oversee, enforce, and support pollution control mechanisms. So they just don't have that in those developing countries. So we know that Japan, Australia, most of Western Europe are going to have improved surface quality, water quality in recent years. Sewage treatment in the wealthier countries of Europe generally equals or surpasses that of what we see in the United States. Sweden, for example, serves 98% of its population with at least secondary water treatment. In comparison, the US only serves about 70% of the population with that same quality of treatment. As you can imagine, if you don't have that infrastructure, poorer countries are going to have a lot less money to spend on sanitation, and therefore they're going to have a lot less water quality control standards. Despite the fall of the Iron Curtain in 1989, parts of Russia, along with the Balkans and Central Asia, remain extremely polluted. They have appalling environmental conditions, and a lot of this is due to just aging infrastructure, if there was any infrastructure there anyway. So a lot of these areas have made massive investments in encouraging progress towards cleaning up environmental problems. Although these areas that we just talked about do remain some of the most polluted places on Earth, unfortunately. It's estimated that 70% of China's surface water is unsafe for human consumption. That's huge. That's as much as we treat in the US, is 70%. And that water in half the country's major rivers is so contaminated that it's unsuited for any use. So what you're seeing on your upper right is an image of a river in China. It's, again, too polluted for any human use. Despite the government spending billions of dollars in recent years, there's still dumping of industrial and domestic waste, and it is at dangerous levels at this point. So again, you can have infrastructure and you can pour money into that infrastructure, but you also need a government agency that's going to oversee that these standards are enforced, that we're not dumping into there and creating a bigger problem, that hazardous waste and domestic waste and industrial waste is all being disposed of properly. In your lower left-hand corner, you're seeing an image from Haiti. This is a ditch in a Haitian slum. This is an open sewer. So notice that people are playing or are around this open sewer. In an open sewer, you can imagine you're getting all types of waste and refuse, and that can be human waste as well, being dumped into the sewer. And that's going to increase all health risks associated with that. So if you're living in close proximity to this, you can anticipate getting some of the health risks associated with having unclean and unsafe water. So this image shows us leading causes of surface water impairments, and a couple of these seem to be pretty obvious to me, and some of those were kind of more of a surprise. When I think about surface water impairment, I tend to think about humans putting stuff on the surface and it running off into rivers and eventually winding up in rivers and lakes and streams. So I do tend to think about pesticides the most, but according to this chart, it is the least cause of surface water impairment. One of the biggest causes of surface water impairment is going to be pathogens. So we talk about that coliform bacteria, things that can cause risk to humans through ingesting. Those are things that cause the biggest surface water impairments. Mercury we talked about when we talked about air pollution and air quality. Mercury, as you remember, is most common. It is found in the air, and when it interacts with water vapor in the air, it's going to precipitate out and it's going to wind up in our water. Other metals are third. We talked about nutrients, sediment, oxygen depletion, pH changes. We didn't talk much about impaired biota, but we talked about these things when we talked about eutrophication of bodies of water, and also we talked about temperature and how temperature can affect the health of a lake or the health of a stream. So these are things that can be controlled, that can be remediated in order to improve surface water. As you can imagine, groundwater, especially groundwater that makes it into an aquifer, is going to be especially hard to clean up. About half the people in the United States, including 95% of people who live in rural areas, are going to depend on underground aquifers for their drinking water. So think about all the homes and the people who have wells. Those wells are tapping into an aquifer to bring what we hope is clean fresh water to the surface. This vital resource is threatened in many areas by overuse and pollution, and by a wide variety of contaminants such as industrial, agricultural, as well as domestic contaminants. We used to think for decades, and we wrongly assumed that as contaminated water moved through the soil would bind to the chemicals, pulling it out, and that what we'd be left with entering the aquifer was clean water. And we know now that that's just not the case. So when you dump chemicals, some of that, at least some of it, is going to wind up in your aquifer, and that can contaminate the aquifer. The EPA estimates that 1.2 trillion gallons of contaminated water seeps into the ground in the U.S., and that's a pretty significant amount. This leakage is coming from, or the seepage is coming from septic tanks, leaking underground storage tanks like what you would see at a gas station, a tank that would hold gas, those leak. Municipal and industrial landfills also are going to leach contaminants into the ground. Waste disposal sites, surface impoundments, agricultural fields, forests, abandoned wells, all of these things are leaching contaminants into the aquifers and therefore into our groundwater. When you have a deep underground aquifer being contaminated, it is possible to clean it. We do this by pumping water out of the aquifers, treating it, and then pumping it back in. And you can imagine how expensive it is for as large as an aquifer is to pump all that water out, clean it, and just put it right back. So the goal is not actually to have to clean all the aquifers, it's to prevent those contaminants from going in the first place. This image gives us a really good idea of all of the challenges we have in preventing groundwater pollution. So as we mentioned in previous sections, we have an aquifer recharge zone. This is where water is going to enter the groundwater. Above that, we have an impervious rock layer. That means nothing can get through. And below that, we have an impervious rock layer. So this kind of acts like a bowl, and water is going to collect in this shallow aquifer. Now, some problems that we have with groundwater is this impervious rock layer. Sometimes it becomes pervious, and we get fractures in that. And so all of these places, you get holes in your impervious rock layer, those are going to be places where pollution can seep into your shallow aquifer and potentially into your deeper aquifer. As we talked about on the last slide, some sources of those groundwater pollution can be abandoned wells. So remember that a well is going to go through the impervious layer to get to that water down in the shallow aquifer. Well, if you have an abandoned well and it's not functioning anymore, that is a place where contaminants can enter that shallow aquifer. Any surface runoff from vehicles can enter through those fractures into your shallow aquifer. Injection wells are going to go deeper down into your deep aquifer. Again, this is creating a hole in your impervious layers. If water can come out of it, certainly pollution can go down through it. Wells at homes can be places for pollutants to enter, as well as leaking septic tanks. We also talked about gas station underground storage tanks. Those can leak as well. So there's a lot of sources where the groundwater can be polluted, but if we can do some simple things such as making sure our septic tanks don't have leaks, making sure our groundwater storage tanks don't have leaks, making sure we're treating surface runoff and not just sending it straight into the ground untreated. Those are things that we can use to prevent groundwater pollution. We know we're not supposed to dump trash into the ocean. However, we have really few controls for preventing ocean pollution. Coastal bays, estuaries, and shoals and reefs are often overwhelmed by pollution. They're the closest to the shore. Dead zones and poisonous algal blooms are increasingly widespread. If you remember from a couple sections ago, we talked about algal blooms being the result of a nutrient overload or eutrophication, and that can kill off every other bit of marine life you have in that water. Toxic chemicals, heavy metals, oil, sedimentation, all of these are going to affect some of the most attractive and productive ocean regions. So these are the ones that are a little bit more shallow. Think about your coral reef regions. Discarded plastic, flotsam and jetsam are becoming a kind of a sign of a human impact on the ocean. We're seeing more and more plastic, and we're going to talk about that in just a second. 6 million metric tons of plastic are tossed from ships every year into the ocean. This is just from ships alone. This plastic can ensnare and choke seabirds, mammals, even fish. Recently, we discovered a very large part of the ocean, specifically the Pacific Ocean, that has a soup of plastic refuse. We started calling it the Great Pacific Garbage Patch. It has a slowly swirling vortex of plastic refuse, and it's in two convergence zones. So you have these two currents that are coming together in this convergence zone. So it's pulling currents of plastic trash into one location. So what's essentially happening from ocean currents and this floating plastic, which is less dense than water, it stays on the surface, is we're pulling trash from all over the world into two locations. One of these Pacific garbage patches is between Hawaii and California, and the other one is closer to Japan, just to give you an idea of how big of a problem this is. Both of these Great Pacific garbage patches are the size of Texas. Each one is the size of Texas. And so recently we're discovering that in the ocean we have one of the world's largest garbage dumps, and it's mostly plastic that's sitting there. This shouldn't be anything new to you. We know that plastic in the ocean is deadly to marine life. What you're seeing are images of how plastic and oil and other pollution is going to affect marine life. Marine biologists estimate that plastic cast-off nets, so from fishing, plastic beverage yolks, those are the things that your six-pack come in, those little rings of plastic and other packing residue, can kill hundreds of thousands of birds, mammals, and fish every single year.